Welcome everyone to this session, Rancher Integration with AWS Services, Possibilities, Challenges, and Outlook. My name is Dominik Wombacher. I'm a Senior Partner Solutions Architect for SUSE at AWS. I help SUSE to bring their products to AWS, but also partners and customers to optimize existing and migrate new workload to AWS. The agenda for today's session, we go from Rancher by SUSE to Rancher on Amazon EKS. We dive into the integration with AWS services and take a look into the future. But first, let's get an understanding about SUSE Enterprise Container Management and Rancher Prime in general. If you start with Kubernetes, you might have just one cluster, but with time, it's quite common that you have multiple of them. So you need testing, production environments, and will probably run different clusters for different types of workloads. In this multi-cluster world, it's important to have a solution that helps managing all of them from a central place. With Rancher, there is no difference which Kubernetes distribution is used. It could be, for example, Amazon EKS, Rancher Kubernetes Engine, or K3s. Rancher supports basically every CNCF compliant Kubernetes distribution. Without Rancher, you have a separate cluster, maybe in different AWS regions and also on premises, and you have to manage all of them separately. By adding Rancher into your environment, you get your single pane of glass of all your clusters, including central authentication and access control, application deployment, cluster upgrades, and much more. Rancher can also take care about the infrastructure deployment for you. So a new Amazon EKS cluster is basically just a few clicks away and can be fully managed by Rancher throughout the whole lifecycle. The open in open source also means freedom of choice. So there's no vendor lock-in. Everything that Rancher does is configured and applied in your Kubernetes cluster in a way that you could remove Rancher at any time without risking the overall stability of your cluster or your applications. So now that we understand ECM, what's Rancher Prime? Compared to Rancher, which is an open source project and mainly supported by the community, Rancher Prime is the commercial offering from SUSE with enterprise support and defined SLAs. This includes, for example, technical support, which not just covers Rancher itself, but also the underlying container and Kubernetes stack, and a large range of certified integrations. The SUSE support team will assist to keep your business running, to troubleshoot issues, and optionally work with you on root cause analysis to define corrective actions. And to get directly in touch with subject matter experts, you can get access to a dedicated Slack channel as well. There are several professional service offerings available to assist with your project, and also a customer success manager that can work with you and provide different types of go-live support like credits or trainings. To learn more about Rancher Prime, the Rancher Prime offering, just talk to your SUSE or AWS representative. They're happy to provide you further information about that and guide you on your journey. Let's now talk a little about the architecture and the setup of Rancher on Amazon EKS. First, I want to briefly talk about the Amazon region design. So mainly how Amazon defines regions and availability zones. AWS has 31 regions and 99 availability zones around the globe. And there are 5 new regions coming soon, which are Canada, Israel, Thailand, Malaysia, and New Zealand. And a region is a geographical location, and this location contains multiple availability zones. And the networking between availability zones and the transit is redundant. Every availability zone consists of one or more independent data centers, each with redundant power, networking, and connectivity. AZs are many kilometers apart from each other, although they are all within a roughly 100-kilometer range of each other. This provides high resiliency and low latency. If there is an issue with one availability zone, it's unlikely that this will affect other availability zones in the region. The Rancher on Amazon EKS architecture. Amazon Elastic Kubernetes Service is our managed service offering for Kubernetes, which means that Amazon takes care about high availability, patching, and scaling of control nodes. Then we also have EKS Anywhere, which is based on EKS distro. That's the same software stack which also powers EKS on cloud, but you can install it on premises. And then we have Rancher as our management solution. When we take a look on the architectural diagram and we go to the left side where we have the AWS managed VPC, and you can see that every EKS cluster has its own control plane. It's a dedicated control plane just for that cluster. And every of these control planes is split across multiple or spread across multiple availability zones. When we then take a look in the middle part of the diagram, that's the customer managed VPC. And in this VPC, we have the actual worker nodes. So nodes where the application workload is running. The high availability is, for example, achieved by auto scaling of multiple instances, again, spread across multiple of the availability zones. Best practice is to run Rancher on a dedicated cluster, on a separate dedicated EKS cluster just for managing purposes. And that's what you see on the top in blue. That's our high available Rancher setup. It's fully managed by EKS. We have a load balancer for the Rancher UI and API. And as said, EKS takes care about auto scaling of nodes and high availability and all these things. In the middle, in green, we have another EKS cluster, but this time this cluster is deployed and managed by Rancher. But again, on the left side, you see also this cluster, EKS, has its dedicated control plane. I also put spot instances in this cluster. Spot instances are spare capacity that you can use from AWS. And AWS can shut down these instances with a 2-minute warning. You might wonder what's the benefit then. It's actually cost optimization because you get these spot instances for a fraction of the price of an on-demand instance. And it's very good if you have a workload that can be interrupted and resumed, like batch processing or something, because then it's not a problem for you in case the spot instance get reclaimed and the new instances get deployed, because you can just resume your workload. And at the bottom, we have another option. It's an RKE cluster. So it's also fully managed and fully deployed by Rancher. But this time, Rancher deployed EC2 instances. And on top of these instances, RKE was installed. In that scenario, the control plane is also running in the middle part in the customer managed VPC as next to the worker loads actually. And then on the right side, we have on-premises. So it could be connected via VPN or direct connect or something. And in this example, you have an EKS Anywhere cluster running there, and you have a K3S cluster there, also managed by Rancher on AWS. So it's the same tool, it's the same way There's no need to have a separate solution or any individual kind of management. Now that we talked about the design and all these involved parts, I have a question for you. So remember the EKS cluster that we saw on the top, right? So dedicated to Rancher, where you need Amazon EKS, a VPC, subnets, load balancers, worker nodes, and Rancher deployment, and all these things. What do you think? How many steps are required, and how long does it take to get Rancher on Amazon EKS up and running? I give you a few seconds to make a guess. 5, 4, 3, 2, 1. With the Rancher setup on the AWS Marketplace, it's actually just 5 steps, and it can be done in about 20 minutes. In case you don't believe me, let's take a look how that works. From the left to the right, we see that the first step is to create an IAM role. Second step is to create a new Route 53 DNS zone or reuse an existing one. Step 3 is to deploy the Rancher setup instance from the AWS Marketplace. Step 4, we assign the IAM role that we created earlier to this EC2 instance. And step 5 is actually logging to the web UI, answer 3 basic questions, and start the setup. And what then will happen is the Rancher setup does all the heavy lifting for you. So deploys a VPC, subnets, spins up an EKS cluster, deploys Rancher on top of EKS, configures load balancing for the Rancher UI and API, and creates a DNS record that you can access Rancher. Go ahead, just try it by yourself. Go to the AWS Marketplace, use the Rancher setup wizard. This QR code brings you directly to that listing. And if you want to learn more about the setup, there's also a link to the installation guide available in that listing. And in case you are more a visual learner, you can also find a video walkthrough in that guide. Except for the deployed AWS resources, there are no further costs involved to get started with Rancher on AWS. That being said, SUSE offers additional premium support. It's also available from the AWS Marketplace, and you can always add this support option to your Rancher cluster that you deployed with the Rancher setup wizard at a later time. So just get started, and if you feel you're ready for projection and you need an enterprise support to have you covered in case something goes wrong, you can always add that option at a later time. Now that you have Rancher running on AWS, how can you integrate it with other AWS services? Those are the different integrations I want to cover today. There are way more possibilities to interact with AWS services. So for example, you have GitOps with Rancher Fleet, and that can also be integrated with AWS Code Commit. But in this session, I will focus on logging, backup, monitoring, and authentication. A quick refresh about some important terminology, like some Kubernetes terms, what a Helm chart is, and then a little about AWS identity and access management. So first, Kubernetes objects. So basically anything which is created in a Kubernetes cluster, like jobs, pods, deployments, everything is actually an object. So, and sometimes, based on my experience at least, resources are referred as object and vice versa. So let's just say, simply speaking, that whatever you declare in your Kubernetes cluster, that's such an object/resource. And then you have Kubernetes annotations. So that's what we see on the right side. These are key value pairs, and they are attached to such a Kubernetes object. They can be retrieved by a client, by application inside a container. And that way, they are used to extend functionality or to perform additional configurations. Helm is the de facto standard package manager for Kubernetes. And a chart is a package for Helm, like an RPM or a dep package is a package for Linux. But a Helm chart doesn't contain any binaries. They describe the desired state. So how do you want that application looks like on Kubernetes? That's what inside such a Helm chart. They are pushed to a repository, and Helm downloads them from such a repository. Then such an installation of an app via Helm is called a deployment. And deployments can be customized by providing different values to Helm. So that basically means you have your Helm chart, then you provide some values like I want to have this FQDN or whatever the configuration value of the application is. And then Helm will take this information and use it when it deploys on the application for you. And under the hood, Helm creates out of your values and the template, which is part of the Helm chart, Kubernetes manifest files, and then deploys the application for you. An AWS IAM role can be used by users or services to get access to resources. And such a role has permission policies attached, and they define what can be done with a specific service, so what I'm allowed to do. And then there is a trust relationship attached to an IAM role. And this defines who can assume this IAM role and performs the actions from the permission policy. Then it's important that we quickly take a look on EC2 instance roles and AWS access keys on the right. Let's start with the instance role. If you attach an IAM role to an EC2 instance, that grants every application which is running on the instance permissions to the resources which are defined in the policy. So that means for a single application which is running on EC2, that's sufficient. That's a good way actually to grant permissions because it's only used by the single application. But if you have containers, Kubernetes workloads running on them, then it's actually a no-go from a security point of view. Because you grant these permissions to all these containers and not just a specific one. To give you an example, Rancher backups to S3. Read-write permissions are required to do that. So you attach it via an instance profile. But then any container, and not just the Rancher backup pod, can interact with S3, with this S3 bucket. So that introduces a risk of data leak or loss of manipulation. So that's something you definitely want to avoid and reconsider. And then we have on the right side AWS access keys, which are long-term credentials. So they normally have no expiry date or something. They're linked to an IAM user. So credentials could be leaked, or the account could be shared and used for multiple different applications, and therefore also might have too broad assignments of permissions or something. So as always, there are might cases where these approaches are good and you should use them, but I really suggest to avoid them whenever possible, and especially in Kubernetes environments. The problem of instance roles or long-living credentials that I mentioned can be solved in Kubernetes environments by using IAM roles for service accounts, or IRSA. With this feature, AWS IAM roles are assigned to a Kubernetes service account. And this service account is then linked to a specific pod, which actually is a specific application. It's out of the box available on EKS, and IRS helps you to follow security best practices like short-term credentials and least privilege principles. And if you use AWS CLI or SDK inside your pod to interact with AWS services, then it's fully supported to use IRSA instead of other credentials. So it's available in the CLI and SDK. How does IRSA works under the hood? I want to spend a little time here because I think it's a super important feature that we provide, and you should really understand how it works under the hood. So the step one is that we have a reference between the EKS cluster and AWS IAM established via OIDC. That's a one-time setup, so you have to do it just once per cluster, and you use the EKS CDL tool for that. The second step is the reference between a service account and a specific IAM role. That's also done via EKS CDL. So either with the account and the role managed by EKS, or you assign a role to an existing service account. That's both possible. Step 3 is Kubernetes resources which are actually configured to use such a service account by an annotation, so by adding these additional configuration values. Then step 4, this is where we have the pod identity webhook. That's something that's running in the EKS cluster, and it's always triggered when a pod with such annotations of a service account comes up. And then this pod identity webhook will change the configuration of such a pod and add additional stuff like the link to the IAM role, a credentials file which get injected so that actually IRSA can be used from inside the pod from a technical point. Step 5 is then the pod, so your application, which assumes the specified IAM role and connects to the AWS security token service. In the next step, in step 6, AWS STS will verify that request. And if everything is fine, in step 7, it's going to assign temporary credentials. And from that point on, you have access with the AWS CLI or with AWS SDK from inside your pod to interact with AWS services based on whatever is allowed in the attached IAM role without the need of any kind of hard-coded long-living credentials. So now that we learned how IRS works and what are the benefits, let's just see how it links to Rancher and the Rancher integration with AWS services. We start with backup and restore, and we use Amazon S3 as target for our backups as high available storage. And Rancher provides an operator to perform scheduled and encrypted backups. And the service account annotation that we need to actually use IRSA instead of an access key can be set when we install that operator via a Helm chart. And that's how it looks like. So it's about adding 3 lines, and that's enough to enable IRSA for the backup operator. And then the backup operator from Rancher creates a service account. The pod identity webhook sees that we have the service account annotation configured, And then it does all the heavy lifting for us and performs additional configuration steps to make RAS available to the Rancher operator. It's quite similar with logging. We use AWS CloudWatch as our central log location. And then we have the Rancher logging Helm chart, which is based on kube logging operator and uses FluentBit to collect and FluentD to actually forward the logs. When there is enhanced logging enabled, then also EKS logs will be included in the whole log gathering and forwarding. And as of today, the service account annotation that we need for IRSA need to be configured after the initial installation of Rancher logging. And yeah, that's how it looks like. When we have Rancher on EKS and we have this enhanced logging enabled, then there are actually two logging resources that need to be modified. One is Rancher logging root, and the other one is Rancher logging EKS. And in both cases, we need to add these 6 lines that you see here to add the service account annotation and to enable IRSA for Rancher logging. Again, the POD identity webhook will see this change and then applies configuration behind the scenes to grant access from the pod via IRSA. Adjusting the configuration afterwards, after the installation, isn't really ideal. So that's why I created a pull request on GitHub so that the configuration can hopefully be done directly as part of the Helm chart installation in future, similar as we saw it with the backup. Let's jump to authentication. I think that's also a very important topic because for smaller environments and POCs, the local user management from Rancher might be sufficient, but in larger environments and or to centralize it, Rancher comes with various authentication providers like LDAP or SAML. And on the AWS side, we have AWS Identity Center, which is, so you have your user management either directly integrated in AWS Identity Center, or you can attach an AWS managed Microsoft Active Directory as identity source. And there are around 300 pre-integrated apps available for Identity Center, but it can also be integrated with custom SAML applications like Rancher. And then we have AWS managed Microsoft AD. By default, it's deployed across 2 availability zones, and you can always add additional domain controllers if you want to. And it's fully managed by AWS. So AWS takes care about the infrastructure, server patching, and you as customer get access to manage the actual AD objects. So it's like your Active Directory that you might know from on-prem, but you don't have to worry about, and you only create your users, your groups, and stuff like that. So when we take a look what's possible with Rancher authentication on AWS, AWS managed Microsoft AD can be used with the Active Directory LDAP provider, which is included in Rancher. For SAML authentication, there is no official AWS provider available yet, but my tests with Keycloak as SAML provider were successful, so that could be used as interim solution if you want to have a SAML authentication against AWS Identity Center. But keep in mind that this is more like a community supported and best effort supported basis. So it's not covered by fully official commercial support and SLAs at that point. Last but not least, monitoring. Amazon provides managed services for Grafana and Prometheus. the rancher monitoring approach is to deploy one Prometheus Grafana stack per cluster, and it's based on the Prometheus stack. That's how such a setup looks like today. In this example, we have one rancher management and 3 downstream clusters. And everyone has its own stack. So that means a separate Grafana login and independent data storage per cluster. What I personally think would be a better approach is when all your metrics from all your different clusters would go to a central place, like managed Prometheus and managed Grafana. With such a setup, I save a lot of resources in my clusters because they only have to push metrics and don't have to run the full monitoring stack. But more important, I reduce the complexity and have this centralized view on all of my metrics across all my different clusters. So let's assume I want to get alerted for a specific event or something. With this centralized approach, I can just configure it once, and I will cover it obviously throughout all the environments. And otherwise, I would have to do different configurations on different clusters. So let's sum up what we described about the state of the integration. You see that there are 2 yellow arrows to logging and backup. What I mean with that is the integration is fully functional from a technical point of view, but it could need some improvement, like better documentation, or in case of logging, that you can also configure it during the Helm installation, during the chart installation, and don't have to configure it afterwards. So there's room for improvement, but you can just start using it right away. Orange on monitoring and authentication. That means they are not well integrated yet. So what I mean with that is that there might be official support missing. There might be still some technical challenges to make it convenient to use or something. So keep in mind when you use AWS Managed Microsoft AD, you can start right away. That's fine, even though I don't have a green arrow there. But for the other things, there might be, there's just room for improvement. Let's say it like that. And that actually brings us to the outlook, because we talked a lot about these different variations and integrations with AWS services and what's possible today. But how might the future look like? Our vision is easy. It's seamless integration that everyone can use and is available out of the box. So we think that leveraging AWS services together with Rancher is something that should just work. It should be well documented or even directly integrated in the Rancher UI or API. Let's put it simple. You focus on your business and we do the heavy lifting for you. Steps that we want to take to to make our vision happen. We want to work on reference architectures that you can use to get started quickly without reinventing the wheel. Continuous improvement of Rancher documentation. So for example, to provide more guidance how to configure the integrations we talked about earlier. Then building an officially supported AWS authentication provider and having IRSA integration into all Rancher core components. So for example, for the deployment and management of EKS or EC2 resources, that requires an access key as of today. Usage of IAM roles and service accounts would increase the security and just simplify the setup. Yeah, and then centralized monitoring. So the ability to directly connect Rancher monitoring to AWS hosted Prometheus and Grafana via wizard through the Rancher UI. So not just the configuration guidance. So that's some part of our vision. Yeah, so feedback is very important for us at Amazon. So please scan the link, so the QR code, or make a screenshot from the link and type it in. Yeah, and let me know what you think about the session. But please also share your Rancher and AWS use cases and what you need to be successful. If you have questions or want to reach out, please use the email address I shared at the beginning of the presentation, or leave your name, mail address, and comment as part of this survey, and I will come back to you shortly. And now it's time to thank you for your attention and your interest in Rancher on AWS, and enjoy the rest of SUSECon 23.